Hello and welcome. Today we are going to look at how to interpret orthographic views into oblique. So in our case we have orthographic views in first angle projection. You have the front elevation, end elevation, and the plan. So and in our question down here we've been told to draw an oblique Cavalier. So we have two types of oblique. We have the Cavalier, which is the true scale. This is the true scale, and we have cabinet. And we have cabinet, which is half scale on the receding side. Now, normally, for you to interpret these views into oblique, maybe Cavalier or cabinet, you need to know that you must have the dimensions of the oblique box. Now in this is our box. Remember, in our oblique, one side is inclined at an angle of 45 degrees, and on this side it is perpendicular to the height. This one is 90, this one form 90 degrees, or you can say it is 180 degrees. It is a straight line. So remember, this side, 45 degree side, is the receding side. So now when it comes to Cavalier, you just draw the way it is, the true scale. But when it comes to cabinet, you're going to reduce the receding side by half scale. So you can say this is half scale. Now, for instance, if you have your width as 50 millimeters, if it is cabinet, you are going to reduce this into half scale. So you are going to use 25 millimeters. Now, in our case here, we have the front elevation, end elevation, and plan. Now, remember, in this our box, we need to have the length, the width, and the height. And this views is going to help us to know our length, width, and height. Now, in our front elevation, we have, this is our length, which is 80 millimeters, and our height, which is 70 millimeters. So we have height is 70 millimeters. Now, in our end elevation give us the width and the height. So we already have the height. This is our height. As you can see, it is the same as front elevation. So this is our height, which is 70, and our width, this is our width, which is 80. Which is 80 millimeters. Again, we have a plan. A plan gives us the length. As you can see, from this point to this point is the same as the length in front elevation, which is 80. So our length remains 80. And then it also gives us the width. As you can calculate our width, we have 60 and 20, which is 80. You can see also 40, 40, which is 80. So from there, we can draw our oblique box using this dimension, length, width, and height. And don't forget that it is inclined. One side is inclined at 45 degrees, and we are saying it is the receding side. So we'll begin by drawing a line, a horizontal line. Remember, we said one of the sides is 45 degrees, so I'm going to use my set square of 45 degrees. That is it. So we have this angle is 45 degrees, and then from there we said that the other side is 90 degrees or perpendicular to our height. So we're going to have our height here. So as you can see, these sides form 90 degrees with our height. Now from there, from our dimension, we have our length as 80, our height 70, and our width is 80. So I'm going to measure 80 millimeters using my compass. I'm going to measure 80 millimeters. So we have that. So we have 80 millimeters on our length. We also have 80 millimeters on this other side. Remember, our height is 70, so we're going to measure 70 from this side. We'll have 70. That is the point of our 70. And then from there, we're going to draw vertical lines, which is our height on this this end. So we have that vertical line. At this end also we have vertical line, which is our height. So we have that. Remember our height, we said it is 70. I'm going to measure 70 millimeters. So we have that. We have 70 is our height, 70, and we also have 70. Remember, now we're going to draw a parallel line to this. I can simply use my T-square to draw this line. I have that, and because this one is inclined at an angle of 45, I'm going to use my set square of 45 degrees to draw a parallel line. So we have that, and also from this other side we're going to draw a parallel line to this. So I'm going to use my set square of 45, simply my T square and set square. Sorry, I'm going to use my T square to draw this line on the upper side. Make sure you are accurate. And now I'm going to draw another parallel line from this end. And I'm going to use my 45 degree set square. So we have that as our isometric box, and I'm going to erase all these other lines so that you can have a clear isometric box. So we have our oblique box. So in our case here, now we want now to interpret these views and come up with a solid figure. So we have this part, we have this 20 millimeters in our front elevation, and as you can see, if you extend this line, we also have it in our end elevation. Now in my case, I'm going to use this part as my front elevation, this part as end elevation, and my plan from the top. So we are going to draw this line, which is 20 millimeters of height, 20 millimeters in our front elevation and at the end elevation. So I'm going to measure 20 millimeters. So that is my point of 20 millimeters. So in my end elevation, I have this 20, and remember we also have it in our front elevation. So I'm going to use my set square to draw that 20. So in our case, as you can see in our front elevation, this 20 is not touching our edge on this other end, this edge, this our height. So we have the remaining 20. So we're going to measure this 20 from our front elevation. So from the base, I'm going to measure 20, and as you can see, we have this height of 40. So I'm going to measure 20 by 40. So I have this 20. Remember we said 20 by 40. So that is our 20. And then vertically we have 40. Vertically we have 40. 1, 2, 3, 4. So I have that point. So I'm going to draw a line, a vertical line, from my point of 20 to my line of 40. can erase this other part. So guys, remember we have this shape of L in our front elevation, which is this L. As you can see, we have that L. We have this 20 in our end elevation, which is this 20. Okay, there is something I want you to understand now. As you can see in this part of our end elevation, we have this slanting height, and also so we have this slant in our end elevation. So this slant is in our end elevation, we are viewing it in our front elevation as this part, this height of that. You can see we have 40. Remember the old height is 70, so subtracting 40 from 70, we have this height as 30. So we have this slant height, which is this one in our front elevation, and which is also this part in our plan. So remember now, in our plan we have from this length as 80 millimeters. Now we don't have the exact length of this slant, and remember we have it in our end elevation, and it is also part in our plan. So remember from here, if we can extrapolate those lines, so if we have this one is 80, this one is 40, so this part is also 40. So from my plan, from this line, the upper horizontal line, I'm going to measure 40 millimeters, which is the mid of this line, or I'm going to bisect this line so that I can get this point, that point of 40. Side that I can join now my line, the slant height. So I can join my slant height from this point to the point of 40. And remember we have this one as 20 millimeters. So I'm going to measure that 40. So we have that 40. I have that 40 in my plan. So I'm going to join to show you that slant height. So I have that line. Now from this other point, we want to measure this, a line same as this. So I can use my set squares, a line parallel to that. You can use your set squares. So you want a parallel line, so to that point. So remember the length of this line should be the same as that one. So I can use my compass and transfer this, or I can simply transfer this length, a parallel line to that on the upper part. Remember it is 45 degrees. So I'm going to transfer that. So we have it as that. So we have that 20. Remember also in our plan we also have this part, which is 40 by 20. So we have this 20 and our remaining length is 40. So from there I'm going to draw this line, going to join this part. So we have that is our 40, and on this upper part we have 40. So we also have this other slant height, and as you can see in our front elevation we have this L. Remember this height is 40, which is this 40, this 40, and then from our 70 we are remaining with that. Now this is our 40 remaining with that. If you're going to draw a line from this point towards the end, remember now from this point to the top is 30 millimeters. So I'm going to draw a line from this part, a straight line. So we have that line, and we're going to drop this part so that we can get this, our length of 80 millimeters. So I'm going to use my set square and drop this other line. So we have that. Remember, it is this part in our end elevation. Remember we said here is our end elevation. As you can see, this part. So we want to show where this rectangle is, and this slant. So we have this slant and we have this rectangle. So from our point here, this point, we're going to measure 20 millimeters. Remember now, this 20 millimeters is this 20 millimeters. We've been given here is 20 millimeters. So from this part, I'm going to measure 20 millimeters. And remember now, this part and this slant is at the same point. So I'm going to show you. I'm going to measure 20 millimeters. 20 millimeters from that point. That is my point of 20. Also, so I'm going to join this vertex to the other vertex down here. So I have that. So you have that slant, and again this part to this part. So we can use you can draw a parallel line, Remember we are just using our set squares to draw parallel lines. So we have that. So now we can complete it. Remember, we cannot leave our drawing hanging. So from there, I'm going to draw a parallel line from this, a parallel line to this on this other surface. So I'm going to use my T-square and draw that line. So I have that line, and from there, we said we cannot leave our drawing hanging. I'm going to drop the height, that you can see the height. So we have that height. Now we're going to join this part to this end. So I'm going to join so that you can see. So guys, you can outline our work and see if we got our views right. So we can show the required part. Have that line, have that other line. Have that line. Make sure you use your HB pencil to show your outline. I have this front elevation. So this is our final oblique Cavalier projection. So we have we can confirm our views. So in our front elevation, we have this part, which is this L. We also have this upper part, which is this one, the slant height. Remember, we are seeing this in our plan and in our front elevation. And also in our front elevation, we have this slant shape of a triangle. It is this one, this shape of a triangle. And we are done with our front elevation. Now, in our end elevation, remember, this is our end elevation. So what we are seeing in our end elevation, we have this part, which is this line. We have this a small rectangle, which is this rectangle, and we have this other part, which is this other part. So as you can see, we have captured all our end elevation. Now when it comes to our plan, we have this part in our plan. Remember, we said it is this slant. We have this other side, which is this one. We have it there. And then we have this other rectangle, which is this rectangle, the slanting. And then we have this surface, which is square. We have here 60 by 60, so which is this one. So we have it as our rhombus, 60 by 60, and that is the end. Thank you guys for watching, and subscribe for more.